Hello and welcome everyone to day 3 of the SciPy 2018 Lightning Talks.
The third day.
The third day.
Index 2.
Yes, as you reminded us yesterday.
Oh, is that right?
Next one, yeah.
Yeah. Okay. Hello. How's your SciPy going? That's right. That's right. That's more applause than the projector usually gets. So that's good.
So before we start the official Lightning Talks today,
the thunder is going to roll in. Oh no, that's not the way it works.
We're going to have Stefan and Juan give a very blurry introduction to their
That was so
book.
fast.
Yeah, it was fast.
It was a blur.
Elegant SciPy, and I'll let them take it away from here.
All right.
Out further interruptions.
Okay, so we are giving away some books. Let me first tell you about the books. Actually, the first thing I want to mention is that 2012 was my first SciPy conference. I hope everyone's having an awesome conference. But in 2012, I had not written a pull request. I had never contributed any code to any of these libraries. And now I've written this book. And so, yeah, thank you for the awesomeness. And I hope you all have similar life-changing experiences here. Okay, so Elegant SciPy. So when I approached Stefan about writing the book, he was like, oh, I don't know, the docs are really good, and they are really good. Thank you for the SciPy sprint, documentation sprint. And I don't want to do a cookbook either, because that's what Stack Overflow is for. And so we ended up writing this book that basically tries to teach you all of the parts of the SciPy library and a bit of NumPy, a lot of NumPy, I think. Through real applications, sort of start to finish. So this is one of the applications. If there's any Russians in the room, I'm going to butcher this, but Sergei Gorski.
You did great.
Thank you. Went around Russia in 1909, before color photography was invented, and took these 3 pictures. They are on a black and white film, but he puts this color filter in front of each picture, so you can see that the pictures don't look the same. They just depend on the color filter that's been on. So we use scipy.optimize and a bunch of other functions to align the channels. You can see that they're not perfectly aligned, and you end up with this beautiful color image that was created before color photography was invented. So that's pretty cool. Whoa. Oh, yes, sorry, one more application. I also learned from Stefan, and Stefan, who learned from his dad, a lot about radar data processing, and we used all of the FFT modules in SciPy to reconstruct this 3D view of an opencast mine using radar data. So that's the sort of stuff that you can find in the book. We've got 8 chapters corresponding to 8 different parts of SciPy. Actually, the 8th chapter is for Matt Rockland's tools. I don't know if Matt's around. He is around. Anyway, great library. And so if you want to enter, please send an email right now to raffle@elegantscipy.org, and in 1 minute, we will announce the winners. So take out your phones, take out your laptops, and send an email. And in the meantime, Paul and Anthony are going to provide the entertainment.
What?
I only warned Anthony, and I only warned him like 5 minutes ago. So.
All right, so I've got some really bad...
Oh, that's good. Oh, yeah, I have some too. Yeah.
I've got some really bad Python jokes for you here. I'm going to read them. They're not original.
As opposed to all those good ones we said the last 2 nights.
I mean, they're not like yesterday at all.
Nothing
really.
like...
So why are you always smiling, Paul?
Why? I don't know.
That's just your regular expression.
Oh! Nice.
There we go.
Nice.
What's the object-oriented way to become wealthy?
I don't know.
Oh, come on. Inheritance.
Oh!
Me or them?
What?
Oh, yeah.
What was the comment?
Use the microphone, apparently.
Oh, okay.
Yeah, I don't know who. It's probably to me, but... Yeah, I got too excited.
He's too excited.
Yeah.
It's okay. Anthony,
Well,
Anthony, it's okay.
It's okay. I know.
It's going to be okay. We're going to make it.
If loving you is ROM, I don't want to read right. So.
That's... Oh. Nice. You executed that one well.
Yeah. Yeah, I mean, we had a nice pool there. Sorry.
All right.
Oh, there we go.
Oh, and the time's up.
Our stalling is over.
All right, Stefan, do your thing. Sure, why not?
Right. So we'll try and do this live. You remember how this went last year, right? Yeah. I do have an internet connection today, though.
Do you?
We'll find out soon enough. Yep. OK, emails coming in. Whoa, 108 emails.
Nice. I'll also mention we didn't have time to sign them, but for the rest of the session, we'll be near the back. So come and, if you want a signature, it might not be important to you.
It's GPG, right? We're going to have a key signing party?
We're just going to put our fingerprint on it.
Oh, Stefan, we couldn't hear you, but Stefan said we're just going to put our fingerprint on it.
All right, so finding the email addresses, pipe that into a text file, parsing the text file. Let's put all that into a list of people. OK.
Oh, no.
I knew this was a bad
Come
idea.
on.
And we are out of time.
Oh, Jesus.
You're not going to be able to live debug this. I'm sorry.
Oh, my God.
OK.
But you're going to try, though, apparently.
Well, I have a whole bunch of emails in there.
Well, did you,
I know that
remove
guy.
the duplicates, right?
Regular expression, that explains it.
No.
All right. I will fix this and be back in.
So, do you
right.
do JavaScript for a living, or?
What does this say about the quality of the books that people are reading? Is this the reason you're giving these away? Is this just your way of finishing up the book? You really couldn't figure this out, and you need live debugging help?
Yeah, OK. I'm not going to fix this right now.
Oh, good God.
All right, let's give Stefan and Juan a big round of applause.
Actually. Wait. Yes.
Oh, he did. It's the applause that helped. Maybe we should give him more applause. Some positive. No, not too much. Too much. Peter it out. Peter it out. There you go.
This is a lot of pressure for. Oh my.
Oh, more applause. More applause.
All right.
OK.
Should we pop back in later, maybe?
Yeah. Well. OK. I'll fix the regular expressions.
Now you have two problems, right?
We may try to interdigitate you later with the results. So, all right.
All right, Gordon, come on up.
Yep. Okay. There we go.
Yep. Our next speaker is Gordon, and on deck we have Anthony Psychopaths.
Wow. Come on.
Nice. All right. Oh.
Where is it?
Come on, projector.
Okay.
Yes.
All right. Hi, my name is Gordon. First time SciPy here, and also it's my first lightning talk in my life.
Woo!
Thank you. I actually just heard the terminology lightning talk 2 days ago. Then yesterday I improvised this topic. So there won't be any fancy charts, not even a histogram, although I'm a data scientist. Sorry about that. And by the way, I speak 2.5 languages, and unfortunately, English is half. The other 2 languages are Chinese and Python. Today, I'm going to talk about model performance measurement in estimating probabilities. What I'm really going to say is AUC score is not the king. So in data science, when people computing models in classification problem, this is usually people do. They train a bunch of models on the data, then rank them using AUC score, because the area and RC curve score is the most popular one. There's nothing wrong if you are predicting labels. However, if we are going to do some probability estimation, that could be a problem. So the difference here is very subtle. If you predict labels, you are doing like food, not food, food, not food. Actually, it's a quite difficult classification problem for a dog, especially when it comes to paper towel. Actually, toilet paper. And so the probability estimation, you are not saying either 1 or 0. You're actually saying the chance this being food. Then the definition of good should be changed a little bit. So for example, among all the samples which have estimated probability close to 0.9, approximately 90% of them actually being to the positive class. Then you say the model is good. Now let me show you why AUC doesn't work. So the previous examples, I showed the different AUC score for the models, and they are actually not that different. It's between like 0.7 to 0.75. However, if you look at the probability distribution generated by the scikit-learn predict probe, they're actually very different, especially the light GBM classifier. This is more extreme example. I'm using the same probability output from the XGBoost. So the first one is the original probability distribution. Then the rest of 4 of them, I just did some nonlinear transformation. And if you look at the box plots, you see they're very different. However, if you calculate the AUC score, they're all the same. So what's wrong? Because RC curve doesn't take into account the actual distribution. It only cares about the ranking of the probability points. So what do we do? We can use a Braille score. It's another measurement. Don't worry about the equation. We can go to the next slide directly. Just do a scikit-learn import. I love those scikit-learn developers. They always solve problems. And then we calculate the Braille score again against the previous those probabilities outcome. So this is the same one. You can see the AUC score is the same. However, the Braille score is different. By the way, because it's a loss function, so the smaller number, the better. And then if we rank the models by the Braille score again, the LGB light GBM model dropped down to the bottom, and others about the same. But what about if you want to use light GBM because it's super fast? It's actually faster than logistic regression and faster than my talking. You can still use it. However, you can do some probability calibration. How to do it? Just Google it. I don't have time. Sorry about that. Thank you. Bye.
Very good. Well done. So on deck, we have Had Khan. Are you in? Had? No? OK, then I have to check. In that case, on deck is Claire. Claire's here. You're on deck. So stand by. No, you're not on yet. You're just on deck. OK. Are we...
You can keep making fun of me.
Well, I don't want to start, Anthony, because once I get going, you know, there's no way.
There's no way to stop.
There's no way to stop. It's going to be a flood. So, what do we call this, folks?
Technical difficulty?
Blue screen. That's right. I was talking about dead air. All right, so in the machine learning track, let me get on stage here, so you have something to look at that's prettier than Anthony's default desktop. In the machine learning track, I heard a lot of folks talking about how Python doesn't scale. What are you talking about? It's the only language that scales. Right? I mean, so we need to shed that notion, okay? We need to move beyond this, okay? All right, are you ready?
I think so.
You look like you were. I hope that pun didn't rattle you.
All right, here we go. Hello, everybody. This is actually also my first lightning talk at SciPy, and I think I'm a little nervous. My name is Anthony Psychopaths, as you probably know from listening to these lightning talks before, and I recently, back in April, joined QuantSight, a new startup, that is focused on sustainable open source, so I wanted to tell you a bit about what we're doing and how we're involved in the community and everything. So, who is at Quantsite? Who are we? You'll hopefully see a lot of familiar faces on this list. So Travis, myself, David Charvino, Saul is actually here, P.R. Peterson, who's been involved in lots of things over the years, and a whole host of other people, Carlos from Spider as well. So this is basically the team as it stands now, and we're growing every day. So, and our goal is really to help make open source more sustainable, and we'll talk a bit about what that means, but you know, mostly it's on the customer or client or company facing side. So we're trying to balance customer needs or client needs or company needs with managing the communities and helping make sure that the community is also happy simultaneously. And so that's kind of our shtick. It's a big idea. And so to do that, we really intend to be very community driven. So there's a couple of different aspects to that. So one side is that we have this roadmap effort, which I know a few of you have, I've interacted with you, since that's one of the things that I'm leading and interacting with. And so our goal is to help make sure that all of the projects out there have a clear idea as to what their future direction is. And getting that message out there about what they want to do in the future. And then on the other side, we have sort of a Quantsite Labs notion where we're hiring open source developers to actually do open source development. And if that doesn't work out for whatever reason, we're also just providing funding for people to work on projects as freelancers. So and that's another aspect of the business. So. And then on the business side, there's a few different methods that we have. So one is for businesses, right? So we're helping you prioritize, if you run a business, your needs in open source. What are the actual things that you want to get out of the open source projects that you're using already in your company? The second one is identifying talent that's out there in the community and being able to hire that talent to do the things that they're already doing on those projects, not to hire them and for them to go down to sink into some black hole where they're not going to be productive to the community anymore. And then the third is to help mitigate the risk of using open source software. So big enterprise systems is sometimes something that sometimes comes up. And so helping do audits and provide a release valve for features and pieces of and basically some insurance policy against that open source project remaining alive and active. And to that effect, we offer open source subscriptions. And so there's various different levels that you can go and read about in terms of what we'll provide for the open source. If you buy into an open source subscription, what does that give you as a business? And Gil is about to kick me off, maybe? No? Okay. So you can go and read about this on our website, and we're pretty excited about it. And then the last big major push thing that we're doing that you can also, everyone here as a developer can go and sign up for is this website, Open Team, where we're growing it and we're building it every day. But basically it's a place to go and say, hey, I use these tools, and I know I use these tools, and I can advertise that I'm using them. And
thank you so much.
Thank you very much. So
very well done. I'm teeming with excitement.
Openly.
Yes.
Yeah. All right.
All right.
I'm getting off the stage for about 5 minutes.
For about 5 minutes. Thank you. We'll appreciate that. So on deck, we have Mark Garcia. Mark, are you here? Awesome. I see you. Oh, hey, Anthony.
Hey.
Where'd you go?
I thought I was supposed to be down there. No. It hasn't been 5 minutes. Do I need to go into timeout or something? Is that?
But we'd appreciate that, sure.
Okay, yeah. I'll just be over there.
Just be over there?
Yeah.
I'll see you later. Hey! No, we're not doing it.
Oh, yeah. There we go.
Take it away, Claire. Yes, you're on now.
Thank you. So hopefully I can fit this in. This is not what I signed up to talk about, but I just want to tell you about it because it's really cool. I have to talk into the microphone. Okay. So stop using up my seconds. I'm a type 1 diabetic, and at the moment this MicroPython board is showing my blood sugar through the color, which I just did here at SciPy, and I thought it was really cool. And I thought I'd mention it. I thought I'd mention it in case any of you are interested in the technology stack, because some people have asked me about these things. So this sensor on my arm is reading my blood sugar, and it has a third-party transmitter over it, which is transmitting it to my phone, or Bluetoothing it to my phone, which is sending it to a Heroku server in the cloud. And then this is retrieving it from that server. And it was actually super easy once I got connected to the Wi-Fi. That was by far the hardest part. It's just like a tiny amount of code like this, if you can see it. Well, you can come and ask me. But it is courtesy of the server itself, and the upload ability is courtesy of a thing called the Night Scout project, which gives you a little online view like this, which is really cool. And this is their project, which I haven't been involved in. I've just recently become a user of the project. But it's an open source project for people to look after their blood sugar and look after their children's blood sugar. Okay, so if you are interested in any of that stuff, please feel free to come and talk to me during the sprints or today, and I'll tell you all about it. But what I actually wanted to show you was something else. So I work in bioinformatics, and we deal with a lot of high-dimensional data, either like gene expression or maybe just clinical data with lots and lots of variables. And I find myself doing dimensionality reduction a lot, so stuff like PCA, if that's meaningful to you, just to explore the data. And I wanted to try, I found myself doing a bunch of different methods and playing with parameters, so I wanted to try writing a little web app to do that, and this is that web app. It's a Plotly Dash app. I hadn't used Plotly Dash before, and it's pretty nice. So this is, how long have I got? A couple of minutes. So this is currently showing, I had to use some data that I actually had the right to use. This is currently showing the microbiome of my daughter. If you don't know what a microbiome is, it involves gut bacteria and it involved nappies. And this is a PCA plot, so these are just samples taken at different times. And so I could switch to looking at, say, the third dimension instead of the first, and the points will move around. And I could color by some of the metadata I've got available. So the orange ones are measuring an actual probiotic, which we had given her, and the blue ones are measuring her. So you would expect the orange to be a bit separate from the blue, which they are. And if we go back to the first one, you can see it's probably the widest separation of samples. Or I could also color by time, the time that the sample was taken, which is a continuous variable. So at the moment, it does a couple of things. It does PCA, it does multidimensional scaling, which is just the classic way of trying to embed and preserve distances. This is just doing Euclidean distance. And it does TSNE, which has a little button to click because TSNE can be quite slow, and I don't want to do it on the fly because everything will slow right down. But the results for TSNE are going to vary depending on the value you set for the perplexity, which is actually part of the point of having it in an app, because one criticism TSNE has attracted is that by changing this parameter, particularly this parameter, you can kind of make it look like anything you want. And that's a criticism when people are publishing results in scientific papers. But if you are exploring the data and you can easily play with that parameter, then this sort of becomes a feature, because the parameter really is a balance between the global scale and the local scale. And after going to the talk yesterday, I would like to put in UMAP. That looks really exciting. And I'm doing a bit of hacking at the moment to improve the data format that you put your data in. So if you're interested in trying this, please talk to me. It's on GitHub. And I would be interested in your feedback in how you want it to work. Thank you.
Thank you very much, Claire. Oh, yeah, Paul doesn't have a mic. Wow. Gave it up.
All right, so we're gonna let Stefan and Juan have another shot up next. They claim to be ready. We'll see. After this,
After this, yeah. And then who's on deck after that?
And then after that, Julie will give a talk using Stefan's computer, so we're going to have the slides queued up on that.
Oh, using Stefan's computer.
That's right. And
Is
then
there a Julie in the house, though? Oh, there we are.
She knows. Okay. She's here.
Sorry?
And then yeah, Stefan knows. Did you see my email? I did. Oh, I'm sorry. I sent you an email. Well, that's why I'm saying it now. Will you check your email?
I'll check.
Thank you.
You never call. You never write.
That's right. This always happens with him. I don't know why. Just
He's automated.
He's automated it, right?
Yeah. It's automated friendship. All right, there we go. Take it away, Mark.
Hello, everyone. I'm Mark. You will find more information about me under the name Data Pythonista on the internet if you care. This is a lightning talk because I want to tell you my opinion about the importing all the libraries in using aliases, for example, NumPy as MP and Pandas as PD. Okay, but before we start, just a short disclaimer. Many amazing developers use those things I'm going to criticize a bit. So just take this as my personal opinion. And just a quick note, I think it's worth, I won't be offended if talking about amazing developers, we spend just a few seconds of my lightning talk to thank all the people who is building these tools, building all this ecosystem of Python and Python itself, and especially Guido van Rossum for all the work they are doing for us. And I want to quickly thank Damian Appel and the Jupyter team because they saved me so many hours preparing talks. I give a few of them, and it's really amazing to use Rise and Jupyter for the talk. So going back to the topic, importing, that I've been in Python for many years now, and my first approach to using a library like Pandas or any other would be just like import Pandas and using Pandas as the module, but it seems like the community thought that saving 4 characters was very important. So my first reaction was, wow, if saving 4 characters is amazing, how could we make it like save 5? That would be even better. But yeah, then of course, if you import Pandas as P, then you have things like pyplot that you probably import as P, and there start to be conflicts. So after several weeks and actually months of thinking about this problem, I end up with a solution, Python 3, unless you are in the Jurassic of Python and you're in Python 2, Python 3 supports Unicode, so we can do things like this.
Zoom in, yeah.
But I found just a small problem with this. Python 3 supports Unicode for your code, but not all Unicode in identifiers, so unfortunately that didn't work. Oh, you can fix that? Oh, we need to talk. Just to be clear, the identifier didn't work, but you can do things like this, and this works if that's something useful for you. So then I attended one of the tutorials, and more than NumPy and Pandas that were so used, I saw things like this. It was a really amazing tutorial, one of the best sessions I had in here. Not for this code, of course, it was the geospatial tutorial. Go to the internet and watch the video if you have the opportunity, because it was really, really useful. But yeah, that was something that I prefer not to see. So yeah, thinking about what's a good practice in Python, I think we have a method on the Python community to know what's good idea and what's bad, that it's basically the Zen of Python. You can do import this, and you get lots of tips on that. Beautiful is better than ugly. We just saw that the most beautiful approach actually doesn't work, so that's not an option. But explicit is better than implicit. I think it's more explicit to use the name of the module. Simple is better than complex. I think it's more simple not to use aliases, just to use the name. And there are many others, like special cases aren't special enough to break the rules. I think that also applies to this case. Readability counts, that's my favorite, and we'll see a bit about that. So readability counts. Why the readability counts? What do you think is the ratio between how many times you write code and how many times this code is been written for someone? What would you say, like 1 to 1? 1 to 2? 1 to 70? The guy with the blue shirt, someone gives more than 1 to 70? 190? Someone said 1 to 90? Okay, yeah. I have no idea, but it's... But literally, it's lots more time. I think really, it doesn't matter how much time you spend writing your code. I think it's important to really write it well because people will be reading at this code. And I'm not talking when your Jupyter notebook is, when you're writing code in Jupyter notebook and you're naming like it Untitled 1023, no one is going to see this code. So yeah, I don't have more time to. Yeah, well, basically that's like some libraries that we have no clue what they are. And if you use the names, that's it. Thank you very much.
Thank you. Thank you so much.
That was a very important talk.
Can you plug that in?
Second round.
Hey, can you plug this in?
Take two. Whoa, a lot of books just fell out.
Could you plug this in for me?
Don't throw the book at me. Come on.
Didn't we make that joke yesterday?
I think we did, but some of the folks weren't here. Let's turn the page. Thank you, Dan.
We made that one yesterday, too.
Yeah. Dan was the one that wasn't here.
Did you make the same pun twice? And it was a callback.
Yeah,
Sure.
All right, well,
I think we
wasn't
covered
embarrassing
that
at all.
one.
Take two.
All right.
Yeah.
Do you want to speak into the mic?
Yes, I said that was not embarrassing at all. So to give you a little bit of an insight into the psychology of writing a book, just after I committed that snafu, this is what I received from one. So incidentally, the lesson is not to reuse your variable names. So this is the kind of honesty you develop while writing a book with someone. All right, so no, don't close the notebook. All right.
Disaster averted.
All right, let's see. So far, so good. All right, here goes the raffler.
All right, we don't have a lot of time, so if you see your name, come running up to grab your book.
All right. You have to be present to win, remember, right?
Yes.
So if you see your name, come on up.
There's no one.
Stefan got one. Phil Elson got one.
Wow.
Hey,
Woo.
all right.
Yay.
We're giving him 5 more minutes.
You got one too? Nice. Nice. Anonymous. Wow.
Here, I can. Yeah.
It's hard to win as anonymous.
Yes. Sorry. There you go.
Prabhu got one. All right. Matt, that's very nondescript. Oh, Matt A. Okay.
I'm not going to throw that.
Hiya, Leonardo. All right. So more. How many more do we need?
How many names do we have? 25. All right.
We have 25 names, but have we given away 25 books?
There.
Anyone want the box? I don't know.
One book here.
I'll try to contain myself.
There you go.
Yes. No.
Okay, shall we do one more? One more?
One more. But we run the risk of a segfault here.
We do.
Are you here? All right.
All right. Great. All right. Thank you guys very much.
All right. Up next, it's a great pleasure to have Julie, our diversity chair, give us an update. Who just got a book?
We just got a book.
Hi, my name is Julie, and I'm an Elegant SciPy winner. So last year, we gave a talk about the different initiatives we'd taken to make SciPy a great conference for everybody. And we wanted to give a quick update on some numbers. So my day job, I'm a data scientist, which means I spend all day in meetings. But it also means that I really value quantitative measures. And so I spend a lot of time counting things. And so last year, from this year, we've seen a 15% year-over-year increase in the number of attendees, and that's awesome. SciPy is growing as a conference. How are we doing in gender diversity? So in the registration flow, we ask everybody for optional demographic information. And from that data, what we've seen is a 37% year-over-year increase in the number of folks who have identified as female, non-binary third gender, or gender not listed, and a 23% year-over-year increase in folks who identify as male. You notice that I'm giving this in relative numbers, and the reason why is because only 21.2% of participants did not fill out the survey. You have an option of saying that you don't want to give your data, and that's totally fine, but these folks didn't fill out any information. And so as one data nerd to a whole audience full, I implore you to give us some information, and then we'll be able to make sure that SciPy is the best conference that it can possibly be. Thank you.
All right. So, Alex Samuel, will you make your way up here if you're here, Alex? Alex, are you here? Yes, you are. Great. And then on deck, we have Danielle.
Yeah.
Great.
All right.
Awesome.
Great. Perfect. How are you going to fill this dead space?
I'm not sure. How am I going to do it?
Awkwardly?
Oh.
Oh, I can need my gadget.
Oh, hello.
This goes directly.
You're so...
Hi, Matt. You're really far away. Is that because the troublemakers sit in the back?
HDMI.
My day was pretty awesome. I got to go to SciPy. Woo! The worst part was like they put me on stage and I had nothing to say. Hi, Matt.
Okay.
All right. Let's
take it away.
Hey, I'm Alex Samuel. I've been to SciPy a few times before, but I never did a lightning talk, so it's scary to be up here. So probably a lot of people work in time and Python, as you may or may not have noticed. There's some selection of libraries available. I did a talk at my local PyData about this for a while ago. It was full of terrible time puns, but I'm not going to make any of them today. Sorry. I wasn't prepared.
Yeah, we don't have any time for that from the audience.
So given all these libraries, we don't really need another one, do we? Well, so of course I wrote one, right? So it started years ago as kind of scratching an itch, but it kind of derailed and spiraled down into a multi-year sort of therapy hacking project when I got home from work after a whole day of meetings and just wanted to write some code without talking to anyone. So now I have a pile of code, and I actually have a pile of unit tests, and I even have some documentation. But no one's really using it. So I thought I'd just come up here and tell you a little bit about it. It's an implementation of times and dates and some related functionality. It's almost entirely in C++ with Python bindings. It has 0 dependencies. It carries its own zone info database, so you don't have to install an extra time zone database. And I have some benchmarks. It's basically as fast or faster than the various other implementations out there. It supports times. It supports first-class dates as well as time of day, so like 12:30 or whatever. And it's a little unusual in that it supports a wide variety of widths, so bit widths, resolutions, and ranges. So for instance, there's a 128-bit time type. You want zeptoseconds. We got zeptoseconds. There's distinct missing and invalid values, so you don't have to use nans for data you don't have versus data that is the results of an incorrect computation. The API is fairly small. It focuses on physical time, so unlike the Python standard library, there's no naive times. All times represent physical times, and there are explicit conversions from physical to local time. And it has rich and fast formatting and parsing, mainly around the ISO-style time and date formats. I also implemented a D-type for each of the time and date types, so you can put them in an ND array. There's ufuncs for most of the values, and so they work. You can, for instance, localize times into a time zone over a vector, an array of times. And that's quite fast. So that's all I have to say. If you are having trouble with your current date and time, and you're sort of shopping for a solution that might be either faster or a bit richer than what you're using, please try it out. Give me a shout. It's on Conda, GitHub, of course. And let me know. Thank you.
Thank you very much. Oh, I need my...
So, Paul, do you want a raisin? How about a date?
Oh, yeah, I was going to make puns about time, but all of mine are dated.
Hopefully there's an adapter.
Hopefully it is the right adapter. All right.
Who's next on deck?
On deck is Kyle Niemeyer. Kyle, are you here?
Thank you.
Woo!
You want to come up? It's
Make
about
your way,
time,
Kyle.
I guess.
Do-do. All right. Take it away.
Hi, everyone. I'm Danielle Quinn. I'm a PhD student at Memorial University in Newfoundland, and my background's actually marine biology and fisheries ecology. This might be the first time at SciPy. This is my first SciPy, but this might be the first time at SciPy that a lightning talk is actually about R. Sorry about that. So what I'm actually going to talk about is a novel way of teaching people how to code. And so really, even though I'm doing it from the R perspective, this could easily be done from the Python perspective, and I would love to talk to you more about that. So first of all, there is an organization called Field School. They're based out of Miami, Florida, and what they do is they provide marine science students specifically with hands-on research or hands-on experience doing real research. It's run by an amazing team of people, and it takes place on a 55-foot research vessel or research and dive vessel. So some of the more popular courses that they offer are marine and tropical ecology courses. Students learn how to free dive, do coral reef surveys. They have a shark and ray handling course where we actually go out and tag pelagic sharks. And so you might kind of think, well, where does coding fit into all this? But as I'm sure we all understand, collecting the data is not the end of the research project. And so because Field School's vision is really to provide people with sort of this full range of skill sets, they agreed that it would be really interesting to also offer a coding course aboard this vessel called the RV Garvin. So why do I teach R at sea? Well, the real purpose of this.
Well done.
Thank you. We want to emphasize the role and importance of coding and statistics in research skills, especially in the area of marine biology and ecology, where things, they're going, but it's been a little bit of a slow start, kind of really getting people to embrace programming. Our hook was a novel twist. Our hook was a novel twist on traditional coding course. And so the way that we did it is we had learners live and work off of the research vessel Garvin for 4 days, and learners rotate between very intense coding and statistical modeling sessions and immersive adventures. So we will spend the morning learning how to write a function and run models, and then the afternoon learning how to free dive and identify coral reef species. So I want to share just a few of the lessons that I've learned, because as I said, this isn't really about R. This is just about how to effectively teach coding in kind of an interesting way. So the number one thing I've learned is that non-traditional spaces can work. It's physically difficult to actually get to the students who are trying to work on the other side of the boat. So sticky notes are really important, and pair programming is really valuable. As I'm sure you would imagine, trying to learn statistics and coding at the same time really leads to cognitive overload. And so the way I managed that was to develop fill-in-the-blank coding templates that basically help learners see patterns in the coding and in the modeling process. Casual evening sessions work incredibly well when everyone is in the same boat, literally and figuratively here. These co-working sessions were amazing. People would just get together. I mean, they don't really have anywhere else to go. They're stuck on the ocean. So they would get together and actually apply what they had learned that day to their own data. And it was really interesting to see these co-working sessions come out, seeing people help each other troubleshoot their code. It was really nice. So we were really targeting students who knew that they should learn how to code, but just didn't quite have the motivation. So I'll tell you, if you were trying to get somebody to learn how to program, offer them 4 days on a boat in Miami, because that changes their mind really quickly. They're suddenly like, yeah, I think I should learn to program. So everything else is what the students came for. How to code is what they left with. And then finally, some lessons learned. Make sure you define your expectations. I'm going to put more time into co-working sessions. Be ready to not have internet. Sun will drain your energy, and make sure that you bring Gravol, because being seasick while coding is not fun, and we had a couple instances of that. So if you're interested, or anyone you know is interested, we have a couple spots left for the next course in September. Thanks.
Thank you.
Thank you very much. That talk was a real bait and switch.
I thought it was Jossum.
Oh.
It sounds like they solved a lot of issues.
Oh. Were there any pearls
did you
from the
use
audience?
Pearl at all? Yeah,
That's good, yeah. Most jokes about the oceans, I find, are a little bit watered down.
But eventually...
I said watered down. Did you?
It seems like most of the students got to the ultimate solution. The ocean is the ultimate solution.
I see. You're getting a bit of salt for that one.
Yeah. All right, Kyle, it's your game now.
Thank you. All right, my name's Kyle Niemeyer. I am from Oregon State. If you're interested in my research, you can check out the website below. My talk is not about that at all. Instead, I'd like to tell you a little bit about a new journal that a few of us here in the audience and a couple others have founded called the Journal of Open Source Education. There's the logo. If you're familiar with the Journal of Open Source Software, or JOS, it's because this is a fork or a sibling of that journal. So with that in mind, I actually want to do a quick JOS update before I jump into Jose or Josie, depending on who you ask or your mood. So Journal of Open Source Software, I've actually been excited to hear a lot of talks over the last couple of days talking about submissions of their papers and their software to JOS. We're about a little over 2.5 years old now. If you want to read more than I have time to talk about, we published a paper last year in PeerJCS about JOS, describing its design and so on, with all the authors, the editors at the time. As of today, we have, literally today, 322 published papers over the last 2.5 years, with an additional 80 under review. It's quite a lot. Woo, yeah. It's expanded quite a bit. Our first year, we only had a bit over 100, so we're growing. Right now, we have 20 members of the editorial board. You can go to the website and see who all they are. We're actually in the process of bringing a few others on board to handle the number of papers. We're fiscally sponsored by NumFocus and all the benefits that come with that. And we've actually just recently established a governance model for the overall publisher of open journals, which includes Arvin Smith as our BDFL, plus 6 steering council members. Okay, so that's JOS, a quick update. So Jose, or Josie, again, who you ask, part of Open Journals, sibling journal to JOS. We actually literally forked the JOS repo, also NumFocus affiliated. So the idea with this journal is to publish 2 different types of articles or content, one of which is kind of similar to JOS but focused more on educational software. So if you're developing software that's infrastructure tool or some other sort of software to be used in an educational context, then it should be, it will likely be in scope. But we're also, more importantly, publishing open source learning modules. And so these are things like a set of lessons or a course based on, say, Jupyter Notebooks, for example. So it's not so much, it's how teaching, using code to teach, essentially. That's the idea there. And the motivation behind the journal, similar to the motivation behind JOS, is to help credit efforts to develop software, either for assisting teaching and learning, the software side of things, or the actual development of this open source computational educational content. Right now, there's really no way of getting credit for putting the effort into developing these things, and it does take quite a bit of effort. So submissions are fully peer-reviewed, like a traditional academic journal. And the idea is that peer review will actually help improve the quality of the software or the educational content that's submitted. So you actually get a paper, a true journal paper, cross-ref, everything. We're a real journal, and you get this paper credit for this material that you've developed. So other than me on the editorial board, we have 8 others at the moment, a few in the audience. Lorena, Anthony's here, Tracy was here, I'm not sure if she's still here, and a few others you may be familiar with and from the greater community. We're relatively small right now because we're in kind of a pilot phase, but as we get additional submissions, we will likely need to expand that editorial board. I didn't put up people's backgrounds, but we cover a kind of range of topic areas. So submitting your software or your content is pretty easy. This is just a snapshot of that submission page. So title, where's the repository, like where's this material hosted, whether it's a software or a learning module type, and then some description of it. And that's pretty much it. If you've developed this and kind of developed it well, then it shouldn't take too long to submit the paper. Quickly, the flowchart of the process is you make your stuff available openly under some repository with an open source license. You author a short markdown paper. Usually it's between 2 to 1,000 words. We try to not make it too long. You submit it by filling out that form I just showed you. Then at that point, it's submitted. It is in a review issue on GitHub. The editor, one of us, will assign 1 or more reviewers who will review it. They'll give you comments and feedback. Everything's in the open on GitHub. It's more of a conversation than the typical journal review process. And then that process will repeat, and so on. We have first, I think, 6 papers under submission. 2 have already been published. You can see it's a combination of these learning modules and software. Our first 2 papers have been published. Both of them are Python. This is about the SciPy Optimize module, and the other one is a Python tool for modeling something. I don't know what that is. And I'll just finish by saying submissions are welcome, and that's our website. Thank you.
Thank you very much.
Thank you, Kyle.
So on deck, we have Stewart Mumford. Skip. Yep. Stewart's a skip. All right. Jim Christ.
Do you want, okay. Jim? Cool. Oh, yeah,
Jim, are you
over there?
All right. Jim's making his way. Great.
Cool.
As a reminder to all of you, there is a BOF at the end of this lightning talk session for planning SciPy 2019. So if you still have energy, or if you don't have energy,
yeah, if you don't have
thoughts,
energy, just go. Especially if you don't have energy.
It's special. Yeah, the lower the energy, the better.
Marius, take it away.
Cool. So who here uses CondaForge? Cool. So just a quick update from what we're doing at CondaForge, just to keep the community abreast. This is a volunteer effort, and CondaForge has grown ridiculously. We have almost 5,000 packages now. That may have some problems for us soon, but we're getting there. So, update on the Forge. So, we've got a lot of bots now. You may have noticed that if you're a feedstock maintainer, there's a bot that tells you when a new version arrives. That bot has made more than 6,000 pull requests in the space of about 6 months. So that's incredible. Woo. So, Python 3.7 is coming. We've heard that some people wanted to install it, and we'll get there. And the next big thing for us is there's a big compiler switch that we're going to do that brings us much closer to what the defaults channel from Anaconda is doing. So that would sort of mostly mitigate all of the problems that you have if you happen to mix those 2 channels. Unfortunately, doing this requires us to rebuild basically the entire graph. So we have to rebuild like 3,000 packages. So this is going to take some time, so bear with us. We're going to try really, really hard to not break any of you in the process. So we have a model in which we can make this work. So don't worry that we're going to break everything. So, and I said Python 3.7 is coming.
Well done.
Thank you, Marius. What was that?
How long is the build queue?
How long is it's short right now. We haven't started the compiler migration. Okay, so Jim is up next, or on right now. And,
is our last speaker.
Is our last speaker.
And so what we're going to do afterwards, while Jim is setting up, is I don't know if you guys heard, but Guido van Rossum has decided to step down as BDFL of Python. So
taking a long vacation on a boat in Miami.
Taking a well-deserved long vacation, and he's keeping his commitment. He's staying involved, but we wanted to just make a small way to recognize him and show our appreciation. So what we're going to do after this talk is we're going to bring the house lights up, and if you feel so compelled, we'd love for everyone to stand up and just sort of clap after. This will be, we'll set this up. It'll work, but.
Definitely.
Right? Yeah, definitely
It'll
work.
Definitely work.
Gil has volunteered to sort of record this thank you message that we can send to Guido after this. So
yes.
If that sounds like a plan, stick around. If you want to call some folks back into the room for this, that's what we'll do.
All right, Jim.
Cool. I'm just going to quick talk about all of the fun, exciting things I've been working on for the last 2 months. So I've been trying to get Dask to deploy on Yarn. For people that aren't familiar, Dask is a parallel programming system for Python. We can deploy easily on Kubernetes. We can deploy easily on other things. We could not easily deploy on Yarn. Now we can. I just want to talk about the whole process that brought up to this. For those that aren't familiar, Apache Yarn is the default scheduling system for Hadoop. So if you have a Hadoop cluster, if it's running jobs in Spark or whatever, it's running on Yarn. It manages the memory and CPU usage across the whole cluster. It's written in Java. It is not easy to use. It has lots of classes. I'm not a Java developer. It is not easy to use if you're not writing in Java at all. There is no non-Java API. You're kind of out of luck. Difficulties with deploying Python Yarn. Hadoop security is complicated. Kerberos is the bottom line. Everything is on top of that. Java-only tooling, again, as I said, and file distribution. You don't usually have access to install things on these clusters. You have to move things around. It's used to, it was designed for Java systems, so it's used to things like jars. Python doesn't really have a jar-like equivalent. Can't just pip con install. Sad day. Oh. Well, then that's the talk. Everything is terrible.
Is this Java's fault?
Oh, there's a sad face on there.
I mean, I heard it took a long time to start up the VM, but
I think it needs more coffee.
Yeah, that's right. That's a callback. I'm looking at you.
Aha, okay. But things are marginally better now. So new fun tools.
Perfect timing slides.
All right, so we have Conda Pack. It's a thing for packaging Conda environments. You can take a Conda environment that's existing, you've got all your stuff in it. It bundles it all up into a tarball or a zip file. Yarn knows how to deal with these. Jars are just zip files. It'll unpack them and move them around. So you can make a Conda environment and distribute it to all your nodes. Skein is a project I work on. Skein is, for people that don't crochet, is a unit of Yarn. Small amount of Yarn, it's just enough for your project to work. This is an easier way of using Yarn. You don't have to write any of the Java. I've already banged my head against a wall for 4 months, so now you can just use this tool, hopefully. We have, for people that just want to deploy Dask on Yarn, we have a project called Dask Yarn, does all of that. We have a nice class you can import. And then testing Hadoop is full of perils. So there is a nice project called Hadoop Test Cluster. It's a pip installable package with a command line tool, and you just spin up a Hadoop test cluster locally, and it works. Examples. So in my small amount of time, I'm just going to talk really fast. Skein is declarative. Looks a lot like Docker Compose or whatever. This is a Skein Compose file for deploying IPython on a node. So I have some amount of resources. I have my Conda environment that I've already packaged up, a couple commands to run. Skein is a command line tool. So here I am starting up my remote IPython instance. I can see all of my running applications. For configuration, if you have remote stuff, there's a key value store that it uses to store things. Right now, I am pulling down the kernel.json file that's been started up on the remote file, and I can then log in with Jupyter Console. I'm not expecting anyone to actually follow this. This is just me talking really fast. And if I run ls, I'm actually not, this is not my local edge node. This is inside of the remote container. And that's all in Python. I didn't have to write any Java. What I just showed you was the user code. Exit that out, and you can see. Oh. If I type correctly, the application shut down nicely. I think I'm probably running out of time. But anyway, if any of this sounds super useful to you, I would love to talk to you. I am trying to find people that use Python on Yarn, how we can make their lives better. I'm on Twitter at JiminyChris. GitHub is jchris. You can find me. I will be here for the sprints tomorrow. We're doing a Dask sprint. If you want to come and contribute to a project, please show up. That's it.
Thank you, Jim.
Thank you so much. All right, so could we get the house lights up?
Ooh, fast.
Wow, that was quick. Can we get them down and then up and then down? No?
If you want to get up, get down.
Oh.
Yeah. All right.
I also want
to. No, that wasn't real. That wasn't real. No, sorry. So, keep them up. So,
up is great.
Up is great. Dim. Okay, this is great.
This is fine.
All right.
Everything is fine.
So I think. Do we need people to move to the center?
It would be nice, but people have their stuff, so I don't know how if that will work. And Gil, are you ready? Okay, you're ready.
We could pan.
I can pan.
We can pan.
I think we're gonna pan and make a video. Yeah, there you go. Some folks are gathering in. That's great. Thank you for taking the lead on that.
We're doing a. I think we're doing a picture.
Okay.
Aren't we doing a picture?
I thought we were doing a video, but we can do a picture.
We're doing a picture. Or we're doing a video. We're doing
it because no picture will capture all of these
So we had a lot of ideas, and none of them panned out, as you can tell.
Oh. So
I didn't hear that.
I also want to,
happy.
while we're setting up, this is looking great. This is more beautiful than I could have hoped for. And I just want to recognize and thank Gil for doing all the timing for all the lightning talks. That was awesome. Thank you, Gil.
Thank you, Gil.
Yeah. And I also want to recognize that we didn't get to a lot of people, so I'm sorry. We need to rethink how much time we allocate to this, or maybe not let Stefan write another book. I don't know. Yeah, so we can, again, at the BOF, we can address that. So yeah.
All right. So
yeah. So
okay.
Is anyone, Eric? Do you want to say something to Guido as we record this video, like on behalf of the conference
just clap?
Well, just so that Guido knows that it's directed toward him as we record this.
I'll say something and then everybody clap.
Okay. Yeah, that sounds great.
Hey Guido, this is the SciPy Conference 2018, our 17th year, and it wouldn't have ever been here without you. So this is our big thank you to you from all of us scientists. Thanks so much. Thank you. Awesome. Great idea.
Were you recording?
All right, everybody. Thanks so much for coming. It was a great year. We'll look forward to seeing you next year. Bye-bye.
Thank you, everybody. Have a great time at the